Okay, hello Trade. So as mentioned, I will be recording on a video on P3 science answering skills of open-ended questions. So basically, I will be going through with you P3 science answering skills, which is all of this here. So you will know how to write an aim, identify change variable, identify measured variable, identify constant or same variable, making a fair experiment, and writing a conclusion. And in order for me to do this, I will guide you through the P3 CA2 science practice paper that I've already given to you with the answers. Okay? Okay, so first, let's take a look at this question here. This question is question 5, page 5 of your practice paper. Peter conducted the following experiment as shown below. He attached different materials A, B, C onto a retort stand. So as you can see here, this is the material. Okay, this is the material, and he is stated here is different materials A, B, C onto a retort stand. Now, just by this sentence, you are able to tell something. They already clearly stated that it is different materials. So definitely in an experiment, you know that this will then be your change variable. Okay. Okay. Now, it is important that in every experiment, you know what is the aim, the change variable, the measured variable, okay, to help you answer the questions later on. In this question, you will see that they have already given you the change variable. Now, let's read on. A 500-gram weight was then tied to the center of the material with a string. So this is a 500-gram weight. So they already tell you it is at the center of the material and it's tied with a string. Now, he observed that A, B, and C would bend but not break. Wait. When we read, we also need to always identify what is the key words within the question itself. Okay? And in this case, it said would bend but would not break. This actually tells you about one of the properties that we have learned. Something about bending. Yes, you get it right. So we are talking about flexibility. The property of flexibility, whether it can bend without breaking. Okay, now we remember we always talk about the difference between flexibility and strength. Flexibility is when we talk about whether it can bend or not bend, and when we talk about strength is break or without breaking. Okay, so it's two different things there. Now, then he measured distance x. Can you see this is the distance x here, this ruler here? Okay, now he measured distance x, which is the distance between the weight, this is the weight, and this is the distance between the weight and the table. So this is the distance, okay, using a ruler. Now, here we have a major keyword here, measured. Sometimes they might write it as measured. Sometimes they might write it as recorded. Okay, it means the same thing. Basically, he is measuring something, a result. He's looking at something. Okay, and this would then tell us what is a measured variable. So, what is a measured variable here? You clearly stated here distance x, which is the distance between the weight and the table. So very clearly, we know that you are right. This is our measured variable. Excellent. So can you see, just by reading the stem of the question, we can now find out what is the change variable and what is the measured variable. Okay, and this would be very, very important in crafting an aim. Okay, now let's take a look at the experiment first. So you know there's different materials, you put the same amount of mass and you measure the distance between the weight and the table. Okay, and it is being recorded down here. As you can see here, material A, distance is 24, material B, distance is 30, material C, distance is 12. Now, So let's do one thing at one time first. Later we interpret the results. Let's first look at the first question. What is the aim of the experiment? Remember, first and foremost, let's recall. What is the formula to write the aim of experiment? Find out if, very good, change variable, insert your change variable, affects your measured variable. Very good. Now, so we know this already. This is the template. So now all we have to do is to find out what is the change variable, what is the measured variable, and we just insert it here. So for this question, we cannot answer this way to find out if change variable affect measured variable because it would just be a general statement. So the answer will be in bold here, okay, to find out if change variable. So we know from our data, let's move up again and see. Change variable here is the different materials. Okay, so let's write to find out if the different materials affect measured variable. So in this case, what is the measured variable that we have identified? Very good. The distance between the weight and the table. Excellent. So let's write it down to find out if the different materials affect the distance between the weight and the table. The table. Can you see? So all that we did was to add the change variable here. Let me highlight in yellow. And we also added the measured variable, which is in green. Can you see that? So it is the same format. So in any case that you are supposed to find out the aim of the experiment, this is what you can do. Are we all okay? Good. Now let's take a look then at the results of the experiment. So here, material A, the distance between the weight and the table is 24. It's further away. That means the weight is further away from the table, which means if I have this weight here, I can move it up. It's further away. Okay. Here, let me move this up. It's further away from the table. Oh dear, this whole thing is following. Yeah, so it would mean that it actually, this thing didn't really bend a lot. Let me try and move this thing. If it doesn't bend a lot, that would definitely mean that the distance between the material and the weight and the table would be longer if it doesn't bend a lot. But so in this one, we can say that this bends the least. Okay, I have demonstrated this concept to you in class, right? So you just have to remember that. And you see, look at material C. Sorry, this is not the bends the least. I made a mistake here. So not 24, 30 cm. This is the one that bends the least. Okay, now then you look at material C. Material C, the distance between the weight and the table is very, very short. So that would mean that the weight is all the way down here, which means that the material has bent the most. Okay, so we know that here mean that it bends the most. Now, since we know this already, let's take a look at the question. Which material A, B, or C should be used to make a water hose? Now ask yourself, if you want to make a water hose, must it be flexible? Definitely, right? Because you want to bend it so that you can spray the water in all directions. So you want something that bends the most. So in this case, how do you write your answer then? Remember, whenever we have explain, first, you are supposed to make a choice, material A, B, or C, and then you are supposed to explain. Now, whenever you see questions like say something like explain or give a reason why or something like that, it means that they are asking you to have your CECC. You remember that? Okay, so let's first take a look. C, the first C is choice. Correct? So you have to make a choice. Now, what choice would it be? Material A, B, or C? Definitely material C, because I want it to bend the most. Choice is material C. Okay? Now, next up, I need to write my evidence. My evidence is from the question itself. Okay? Anything that's from the question itself. So why do you choose material C based on what you see in the question? Oh, based from what I see in the question, material C bends the most. Can you see this? Okay, so that is your evidence. Material C bends the most. That's your evidence. Next, you have to add what's your concept. So what's the concept of material that bends the most? What does it mean? Recall what have I taught you? When it bends the most means it is the most, yes, it's the most flexible. So material C is the most flexible and can be used to make a water hose. That's all. Okay? So now, then you ask yourself, what is the last C where you have to compare? Compare means you need to have all the comparative or the superlative. Comparative words, comparative words or superlative words. Now, of course, this one is not in your answer. This is just the one in bold is your answer. Okay? So compare, you want to write either a comparative word or superlative words. Now, I will highlight to you to show actually in my answer, I have already compared. Which word tells you that I have already compared? Ah, very good. Can you see the word most? Here, when I say material C bends the most, I'm actually referring that the other materials don't bend as much. And the other material is not as flexible. So in this case, with just one word, most, which is a superlative in this case, will tell you that it is already that you are already comparing. Okay, so remember, CECC is not meant for all kind of questions. There's only for meant for explain questions or give your reason or explain why, something like that. Okay, there you use your CECC. And in CECC, not all the time you have to make a choice. Not all the time you have to get to compare. It depends. You have to read the question. Okay, so but most of the time you need both your evidence and your concept. All right. Okay, now let's continue to the second part of the question. It says that the length of material A, B, and C that Peter used in this experiment are shown below. So this is the length of this material here. Let me show you. This one in black. This is the length of the material, okay? So it says that, there's 3 different types of length. So the question is the experiment a fair test or a fair one? Now remember, we talk about fair test all the time. Let's recall. What does it mean by a fair test? Let's just recall and write it here, yeah? What does it mean by a fair test? A fair test would mean that, very good, only one variable is changed and the other variables remain constant or kept the same. Okay, so this is the definition of a fair test. Now, however, you cannot just take this statement and put it in your answer. Why? If you give me this statement, then your answer will just be another general statement, GS, right? And you wouldn't get the marks. So you always need to refer back to the question. So in this case, they say, look at your question again and look at your aim. What is it that you are trying to find out? Let's see. You want to find out if different materials affect the distance between the weight and the table. That's what you want to find out. So here you have already know that there can only be one change variable, which is the different materials. So remember what we always say, what we change is what we want to find out. In this case, we want to find out about the flexibility of the different materials, we change the materials. So we know that the only change variable that we should have in this experiment is the different materials. The rest must be kept constant. So that's exactly what we're going to write here. Now, is this experiment a fair one? And explain. So again, we need your CECC, yeah, because we have a explain question here. So if I say that I only need to change the different materials, should I change the length of the materials? No, that would mean then I would have two change variables, which is wrong. Okay, so in this case, definitely it is not a fair experiment. So my choice, no, it is not a fair experiment. Okay, next one. Then, what is your evidence? Evidence comes from the question. So that means talk something about the question here. Why is this not a fair one? What is wrong with this? So tell me what's wrong with this first. The lengths of the materials are not the same. So we can say the lengths of the material are not the same. So that's your evidence. That means what you see from the question. Now, but you cannot stop here. You need to write the concept. That means you cannot just say, oh, the length of the material is not the same. So, I still don't know why is my experiment not a fair one. So, what should you then write? The concept is now here, right? In a fair test, there should be only one change variable, which is, you must always add this one, which is, because this one would mean that you are not writing any general statement. You are still referring back to the experiment. In a fair test, there should only be one change variable, which is, okay, what should it be? Just now we say, the different materials. Okay, so let's write, which is the different materials. So, what do you then write? Then, so we will say the other variables should be kept the same. That's all. Now, in this case, must we have any comparison? CECC, the last C is compare. No, we don't need to compare because we are not talking about material A versus material B or versus material C. We're not trying to compare anything. So in this case, we just want to know whether it's a fair test or not. Can you see? I do not write this statement over here. That will just give me a general statement. So this statement, I first say that no, it's not a fair test. Why is it not a fair test? Refer to the experiment because the lengths of the materials are not the same. And why is it not, so what if it's not the same? Why is it not fair? Oh, because I learned that in a fair test, only one change variable. And again, refer back to the experiment. In this experiment, the change variable should all be the different materials and not the length of materials. So the other variables should be kept the same. So this is the same format of writing that you should be doing, but of course, you need to read the question and change several parts like these few parts, which is the different materials and the length of materials not the same. Are we all clear? Okay, now let's take a look at another example. This is question 6. Ignore this part over here. This is question 6 of your practice paper again. So Javier had 3 ropes, X, Y, and Z. So this is a rope, 3 different ropes, same material, and each rope has different thickness. Again, we find out what is something that is different here. It has different thickness. So with that, we can always say, hey, this is our change variable. So write it first. Change variable. Different thickness of ropes. Okay, this is the change variable. Now, remember we say in every experiment, find out what's the change variable, find out what's the aim, find out what's the measured variable. So now we find out the change variable, we want to find out the measured variable. Let's see. So he set up the experiment as shown below with the 3 ropes. Javier added weights until the rope broke. He recorded the number of weights that each rope could hold before it broke in the table below. Wait, with this sentence, when I say he recorded, it means it's the same few meaning as if I could to say he measured and then recorded. So it is implying something here. What is it? Yes, it is the measured variable. We can find what did he record, what did he measure? The measured variable here. So as you have said, the measured variable here is the number of weights that each rope could hold before it broke. Can you see that it is the whole statement over here? The number of weights that each rope could hold before it broke. Sorry, it's a whole phrase. Okay, you cannot just stop at the measured variable is the number of weights. The number of weights that what? That each rope could hold. Again, you cannot just stop at the number of weights that each rope could hold. Why? Because if you just mention that, could hold when? In the initial, at the end of the experiment, when? So we say, oh, the number of weights that it can hold before it breaks. I counted the number of weights. So this whole thing here in green would then be our measured variable. Understood? So this is just a practice. So in an experiment, you need to then first identify again your change variable, your measured variable, or even your aim if there is. So just a practice. Again, what is the aim of the experiment? To find out if, yes, change variable, the different thickness of ropes affect your measured variable, in this case, the number of weights that each rope could hold before it broke. Everybody clear? I think it's quite clear from now, yeah? So let me just write it down to find out if the different thickness of the string or the rope affects the number of weights that each rope, it's rope, okay, sorry. So the thickness of the rope affects the number of weights that each rope could hold before it broke. So let me again highlight what is the change variable and what is the measured variable. Clear? Okay, now this is very clear cut already. Now let's take a look at the question then. Oh, so let's take a look. 1 unit of thickness of rope, we need 4 weights to break it. 2 thickness of rope, we need 6 weights to break it. And 3 thickness of rope, we need 8 weights to break it. Now think about it. If I need a lot of weights just to break a rope, that would mean that my rope is, yes, it's strong. Because I need a lot of weight to break it, right? To break it apart. So here, that would mean that Z, which requires 8 number of weights, is the strongest. Very good. And who is the weakest here? X here is the weakest. Okay, now let's take a look at the question. Which rope, X, Y, and Z, is the strongest? So here, again, you are supposed to make a choice. X, Y, or Z. So choice is rope Z. Okay? Now, what is your evidence? Because why? Again, we have the word explain. Now, explain. So evidence here is from the table itself again, from the question. So we can say that rope Z can hold the most number of weight. So we are just explaining what this table means. So rope X can hold the most number of weights as compared to X and Y. So what is the concept then? If it can hold the most number of weight before it broke, here is the property of, very good, is the property of strength. So if it can hold the most number of weight means it is good. So rope Z is strongest, is the strongest. Again, let's check. Did we compare? The last C is compare, right? So what word tells us that we have actually already compared? Very good. You see the word most again. Superlative most. How about others? Okay, we have as compared to. This one we have compared as well. What else? The word strongest. Remember? Strong, stronger is the superlative. Strongest is the comparative. So we have already compared. Rope Z is the strongest among all. So this is the comparison. Everybody clear? So it's okay, not that bad, yeah. Now, however, this kind of question can also come out in a way that it can say something like this. What can you conclude about this experiment? Sometimes the question might come out something like that. What can you conclude about this experiment here without asking you which rope is the strongest? When I ask you, what can you conclude? What can you say about this experiment? What I'm asking you to do is look at the results, comment on the results. What can you tell me about the results here? About these ropes here? What can you tell me about these ropes? So, same thing. Here, actually, you can, it's actually the same answer here, only that you don't have to make a choice. Your answer would be, oh, out of all three, among all three ropes, rope Z is the strongest as it can hold the most number of weights before it broke. Can you see that? Now, so conclude, when I ask you to conclude about the experiment, all that I'm asking you to do is to look at the results again and tell me what is it that you want? You want to find out if the thickness of the rope affects the number of weight each rope will hold, right? So tell me, what about the table here? Oh, from the table I know that rope Z is the strongest. And why do you say it's the strongest? Because it can hold the most number of weights before it broke. Okay, so remember, now in this question, I have also taught you how to not only write an aim, to do CCC, and we have also know how to use to write a conclusion. We also know how to write a conclusion. Yeah? Okay, now let's just take a look at this question. For this question, uh, is actually, let me see, it is actually question number 9 of your practice paper, page 10. However, I removed the question because I don't want to talk about the change variable or the CECC again. So I just want to now touch on the constant variable, or what we call the, when we say constant means it's the same variable. That means variable that is kept the same throughout the experiment. Variable that is the variables, I would say, variables that are kept the same throughout the experiment. Now, let's take a look at this experiment then. So Aisha had 3 different types of material, L, M, and N. So you know this is the change variable already, right? 3 different types of materials. So the type of materials is the change variable. Now, she placed a 10 kg weight in the middle of the plank. Then she measures the length in which the material bend downwards. So basically just to see how much does this material bend. Okay. Now when the weight is released, the material return to the original shape. So that means release means when the weights are taken out, then it will go back to the original shape. Okay. So in this case, let us just list all the constant variables. That means all the variables that's kept the same. There's a lot here. Okay, but the constant variable here is important. You cannot just name every single thing that you see here. Why? Because you must think, how does it affect the experiment if we are actually going to change it? Okay, what I'm trying to mean is a constant variable is kept constant. Why do we keep it the same? Is because we don't want it to affect the result of the experiment. For example, let me give you an example. If I have 10 kg, 10 kg, 10 kg here, if I change it to 10 kg, 20 kg, and 30 kg, am I able to tell that it is the different types of material is flexible or not flexible? No, it will not be a fair test. Why? Because I'm changing the mass of the weights, and this will affect the results of the experiment. So your constant variable are those variable that actually can affect the results of the experiment. So that's why we are going to keep it constant. Okay? Or so in this case, what is the constant variable then? We have talked just now, mass of the weights. Okay? So all of it will be 10 kg, 10 kg, 10 kg. Now what else? Okay, very good. So we talk about the length of the materials. Yeah, the length of the materials here must also be the same. Now, what else? The distance between the two tables here. This is placed on the table, right? The distance between two tables. Okay, now what other things? Mass of weights, length of the material, distance between the two tables. It is also what? If I just take the weight and I just throw it onto this material, what do you think will happen? It will bend more, right? Because I'm putting in more force. Now, but if I put it lightly, softly, what will happen? So there's not much bending that we can see. So in this case, it is also the way how the weight is being placed. Okay, so that would affect the way how you. So some of you might say, oh, we take the weight and then throw it onto the middle of the material here. Of course, it will bend more, right? So in this case, it's also the way how the weight is being placed. Okay, so that's just about it for constant variable. It's actually quite simple. Yeah. Okay, I would like to go through this question because it's actually quite interesting. You need to be able to analyze a bar graph. This is a topic of digestion. Okay, so now let's take a look. Study the classification table below. Now, whenever you have all of this in a bar graph, you should always take a look at the x-axis. We talk about x-axis and the y-axis. Of course, here is all the different types of organs, you know. And then what I want you to notice here is this very important word here, amount of undigested food. Let me see if I can highlight it to you. Amount of undigested food. Oh, sorry. Okay, so this is very important. I'm talking about undigested food. First and foremost, ask yourself, what does it mean by undigested food? Can you think about it? What does it mean by undigested food? Digest. What does digest means? Break down, right? You want to digest your food means you want to break the food down into smaller pieces. So when we say undigested food, food that has not yet been the food that has not yet broken down. Okay, so undigested food, we talk that food that is not broken down yet. So maybe later it will be broken down. So let's take a look in the mouth first. In the mouth, can you tell me, is there any digestion happening? Yeah, definitely, right? So the food is being broken down, right? How? Number one, your teeth will bite and chew on your food. You will chew on your food, and your teeth will grind your food into smaller pieces, right? And some food gets digested as well by the very good by the digestive juices which is in your saliva. So let me just write it down. The mouth, we say that only some food gets digested by the digestive juices in the saliva, and your teeth also breaks the food, also grinds the food. We say grinds the food into smaller pieces. Okay, now, so that is the mouth. So only some of the food gets digested. We still have a lot of other parts of the food that is not yet digested. So we are still left with a lot more food undigested yet. Okay, so that's why we see a very high amount of undigested food here. Now, but I want you to notice something about the mouth and the gullet. What about the undigested food from the mouth and the gullet? Let me show you here with a circle. Make it clear to you. What about this, the one in blue, the circle in blue? Yes, you can see that the amount of undigested food in the mouth and in the gullet is the same. So, what does that mean? The amount of food in the mouth and gullet is the same. This would mean that there is no digestion happening in the gullet, meaning no digestion is happening in the gullet, which is true, right? Why is it so? Because the gullet, what's the function of the gullet? It's just to move the food down to the stomach. That's all. So, that's why when there's no digestion, the amount of undigested food remains the same. Okay? Everybody clear with that? Okay, good. Now let's move on to the stomach. Now, this is the amount of undigested food in the gullet. When it goes to the stomach, there's this part here that has been digested because the amount of undigested food suddenly decreased, right? Which means some of the food here has been digested. Let me try and show you if I can show you the amount of food that has been digested here. Can you see that? The one that I draw? Now, so it means that this part here has been digested already. This, and where does this part here has been digested? It's been digested in the stomach. Understand? So we say that there is a decrease in the amount of undigested food in the stomach, which means there is digestion in the stomach by digestive juices. We know that there is digestion happening in the stomach by some of the digestive juices. Sorry. Are we all okay? Now, then let's take a look. From the stomach to the small intestine, there is again another decrease in the undigested food. Let me draw the decrease again. See, can you see a bigger decrease? Let me color it in red. Now, can you see there's a bigger decrease in the amount of undigested food in the small intestine? That would mean that most of the digestion is also taking place in the small intestine. That's why there's a lot of food that suddenly gets digested. So in this case, we can say that there is a larger decrease in the amount of undigested food in the small intestine, which means that there is more digestion taking place in the small intestine. That's why a lot more food gets digested and very little undigested food is left. Right? So, then let's take a look. Small intestine, this is the amount of undigested food. When it goes to the large intestine, the undigested food remains the same. When it goes to the anus, the undigested food again remains the same. What is happening here? When the amount of undigested food remains the same, what does that mean? It means that there is no digestion taking place. Okay? Very good. So let's just write it down here again. Can you see here? Let me show you so that it will be clearer. Let me see if I can do this. Okay, this way. Here. Now let's take a look at this arrow over here. Color it could be, yeah, green. Oh no. Okay, green color. Now, can you see that there is no change in the amount of undigested food from the small intestine to the large intestine to the anus, which means there is no digestion. That means after it comes out from the small intestine, it goes to the large intestine. Is there any digestion? No digestion. After it comes out from the large intestine, go to the anus. Is there any digestion? No digestion. So that's why it remains as undigested food. And where does all the undigested food goes to? To the anus, and then it will be released out from your body. Understand? Okay, so let me write what I've actually said just now. So we have said that the amount of undigested food remains the same in the large intestine, small intestine and the large intestine and the anus, which means that there is no digestion taking place in the large intestine and the anus. Everybody clear so far? Okay, so there's the amount of food remains the same in the large intestine and the anus and also the small intestine. Why? Because when the food goes out from the small intestine, that's the undigested food. It goes to the large intestine. No more digestion. Why? Because digestion has already stopped in the small intestine. So digestion stopped in the small intestine. Okay? Now, what then happened in the large intestine? There's absorption of water in the large intestine. Now, then where does all the digested food goes to in the small intestine? The digested food in the small intestine gets absorbed by the walls of the small intestine and go to the bloodstream to go to the rest of the body. Are we all okay? So, now if the question asks, so based on the table above, how do you know that there is no digestion taking place in the large intestine? Because the amount of undigested food in the small intestine is the same as the amount of undigested food in the large intestine. That means there is no digestion taking place. Okay? Now, then after which, if the question asks you, how do you know which part of the digestive system, which part of the digestive system have the greatest amount of digested food? That means a lot of digestion is taking place. Which one? Look at the arrows here. Which one shows that there's a lot of digestion or most digestion or greatest amount of digested food? It shows the small intestine. Why small intestine? So you must always use the graph, okay? You cannot use your general knowledge, what you know. Use the graph. So how do you know that there is most digestion taking place in the small intestine? Remember, look at what we wrote here. There is a larger decrease in the amount of undigested food in the small intestine, which means that there is more digestion taking place in the small intestine. So what you're trying to say is that, can you see the decrease here? It is larger decrease. This one also, in the stomach, there's also a decrease. In the small intestine, there is even a larger decrease. So you must see, I use the comparative, a larger decrease in the undigested food. Okay, or we can also say that the decrease in undigested food is the most, or the decrease in the undigested food is more than the other organs. So that is when we know that a lot more digestion is taking place and there will be a greater amount of digested food. Clear?